Hello and welcome. The focus of this video is on understanding the need for creating local refinement regions and also to explore the setup of the box type local refinement under the Create Local Refinement Regions task in Ansys Fluent Meshing Watertight Workflow. Let's get started. For most fluid flow problems, a finer mesh resolution may be required in specific regions of the computational domain to resolve and capture certain fluid dynamics phenomena like the wake regions of the bodies, laminar-turbulent transitions, etc. For creating such localized refinement zones, the usual practice is to define bodies of influence or BOIs during CAD creation. These are geometrical entities created just for the purpose of defining the mesh refinement zones and are not a part of the computational model. Depending on the tool used for creating the CAD model, certain considerations need to be made in order to ensure that the BOIs are defined correctly. For example, when using Ansys Discovery, care needs to be taken such that the BOIs are in a separate component than the actual geometrical entities that needs to be computationally modeled, as shown here. This avoids any shared topology features between the BOIs and the geometry to be modeled, and thereby allowing the users to define BOI-based mesh refinement zones. To avoid potential issues with this process and to also simplify defining the refinement zones, the Watertight Meshing workflow lets the user create BOI type refinement regions using the Create Local Refinement Regions task. Let's now see how we can set up this task. Load the provided geometry into the Watertight workflow through the Import Geometry task using the default settings. Here we have a concept car placed inside an enclosure, which acts as the fluid domain and can be used for performing external aerodynamic type analysis. For this demo, we will not be using any local sizing, so leave the option to No in the Add Local Sizing task and hit Update. The Create Local Refinement Regions task is not one of the default tasks in the Watertight workflow. In order to include it, right-click on the Add Local Sizing task to access its task-specific context menu. And from the Insert Next Task menu, select Create Local Refinement Regions, as shown here. This new task is placed immediately after the Add Local Sizing task in the workflow. In this task, in the Type drop-down menu, you can choose between the two options, Box and Offset Surface. Let's look at the box refinement type in a bit more detail. The box refinement type, as the name suggests, lets the user construct a box around the selected geometry to define specific mesh sizes. There are two ways in which the box can be defined, and these options can be found in the Coordinate Specification Method drop-down menu. The default method is the ratio relative to the geometry size. When using this method, the user has to provide the limits to which the box extends to by specifying the minimum and maximum values as a ratio relative to the length of the selected geometry in that specific direction. Here is an illustration of how the ratio are used to create the box around the selected geometry. As you can see, if the length of the body is L in the X direction and if the minimum and maximum ratios are 0.1 and 0.2 respectively, the minimum extent of the box would be 0.1 into L and the maximum extent would be 0.2 into L from the surface of the selected geometry. Coming back to our demo, let's select car surface zone. Immediately, you will see a graphical representation of the box placed around the selected geometry in the graphics window. This box is also overlaid with smaller size boxes which represent the size of the mesh that will be created inside the box, which is controlled by the mesh size input. The second method to create the box is by providing the absolute coordinates of the minimum and maximum locations by selecting the directly specify coordinates option from the coordinate specification method drop-down menu. These are global coordinates with respect to the origin of the model defined during the CAD creation. For our demo, we will select the ratio relative to the geometry size option with a mesh size of 80 and rest of the options at their default settings. Follow the steps as shown here and create the volume mesh. Here is the generated volume mesh, and you can clearly see the influence of the box local refinement region on the mesh size in the region enclosed by the box. Let's summarize what we have learned. In this video, we first identified the potential issues associated with creating BOIs at the CAD level. We then understood how to set up a create local refinement region tasks in Ansys Fluent Meshing Watertight Workflow and explored in detail the box type refinement region specifications. That brings us to the end of this video.